Guys, this is for Daniel and Tom. I know Emma's been scanning homework for both of you. So Daniel and Tom, when you turn this in, turn in your homework 4.1 through 4.4, and then you'll be caught up for that. So here on problem 1, we're given a matrix A, which has 3 rows and 4 columns. So they ask how many rows? 3. How many columns? 4. And what dimensions is it? The rows by columns 3 by 4. And then they're asking what element is the number 21. Well, that's on the first row, third column, so that's called A sub 1, 3. And then what element is 6, and that's in the second row, fourth column, so that's A sub 2, 4. Then they ask us to multiply 3 times the matrix 4, 0, 2, 5 minus 2 times the matrix 2, 4, 1, 3. So that's 3 times 4 is 12 minus 2 times 2 for the A11 element. And then 3 times 0 minus 2 times 4 for the A12 element. And then 3 times 2 minus 2 times 1 for the A21 element, or 3 times 5 minus 2 times 3 for the A22 element, giving us 12 minus 4 or 8, and 0 minus 8 or negative 8, and 6 minus 2 or 4, and 15 minus 6 or 9. Now for problem 4, we have negative 5 times the matrix 1, negative 3, negative 2, 1, plus 2x equals 1, 3, negative 4, 7. So we're going to add that negative 5 matrix, negative 5 times the matrix over to the other side to make it plus 5 times the matrix, so that we'll have 2x equals 1, 3, negative 4, 7 plus 5 times 1, negative 3, negative 2, 1, and that'll give us 1 plus 5, 3 minus 15, negative 4 minus 10, and 7 plus 5, or 6 times negative 12, negative 14, 12, and that's equal to 2x, so we have to divide by 2. So that means every element in the matrix is divided by 2. So our final answer for x is 3, negative 6, negative 7, 6. And on page 149, they're asking us to make a 3 by 4 matrix from the bar chart, where the students are William, Teresa, Valerie, and Igor for the years 2011, 2012, 2013. So that's 1, 2, 1, 2, the one color, 2, 3, 2, 1, the color for 2012, and 4, 4, 1, 2, the color for 2013. Now the rows represent years, the columns represent students, and the element row 2, column 3 is equal to 2, and that represents Valerie attended 2 concerts in 2012. In problem 7, we're taking it from example 1 on page 157 with an A matrix that's a 2 by 2, a B matrix with 2 rows by 3 columns, and a C matrix with 3 rows by 3 columns. We're not looking at the elements, but just whether we can multiply pairs of them. So if we try to multiply A times B, we have a 2 by 2 times a 2 by 3, and so the inner element 2 matches up, that's circled, and so the matrix is the outer elements, the 2 by 3, so that's the 2 by 3 when it's multiplied. When I try to multiply A times C, I get a 2 by 2 times a 3 by 3, and the inner elements 2 and 3 don't match up, so this is undefined because there's not an equal number of elements to multiply between the 2 matrices. But when I try B times C, I get a 2 by 3 times a 3 by 3, and the inner elements 3 match up, so I can use the outer elements 2 times 3, and so when I multiply that, I get a 2 by 3. But when I try to multiply B times A, I get a 2 by 3 times a 2 by 2, and the inner elements 3 by 2 don't match up, so it's undefined. On number 8, when I multiplied the 2 matrices 2, 4, 0, 1, 3, 5 times 3, 4, 5, 2, 1, 0, I multiplied the first row times the first column 2 times 3 is 6, plus 4 times 5 is 20, plus 0 times 1 is 0. So that gives me 6 plus 20 for row 1, column 1. For row 1, column 2, I do 2 times 4 is 8, plus 4 times 2 is 8, plus 0 times 0 is 0. So that gives me 8 plus 8. Now for row 2, column 1, I do 1 times 3, plus 3 times 5, plus 5 times 1, gives me 3 plus 15 plus 5. And for row 2, column 2, I do 1 times 4, plus 3 times 2 is 6. So now for my 2 by 2 matrix, I had a 2 by 3 times a 3 by 2. The 3's in the middle matched, so my matrix dimension is 2 by 2 for the multiplication. So that adds up to 26, 16, 23, and 10. And for number 9, we want to determine k given the determinant that the determinant equals 2. So the matrix 3k, 2, 4, we're taking the determinant of, which is the diagonals. So that's 3 times 4 minus 2 times k equals 2. So subtracting 12 from both sides, we get negative 2k equals negative 10. Dividing by negative 2 on both sides, we get k equals 5. And number 10, all we have to do is put the system of equations in matrix form. So we have 3x plus y minus 4z equals negative 22, and 2x plus 3y plus 4z equals 32, and x minus y plus 2z equals 16. So in matrix form, we're just taking the numbers in front of the x, y, z's. The first row is 3, 1, negative 4. The second row is 2, 3, 4. The third row is 1, negative 1, 2, multiplied by the column vector x, y, z equals the column vector negative 22, 32, 16, the answers. And on problem 11, we're asked to solve the system of equations, the two equations using Cramer's rule. So we're given 4x plus 3y equals 8 and 6x minus y equals 1. So that gives us the matrix 4, 3, 6, negative 1 times the column vector x, y equals the answers 8, 1. So to take the determinant of A, we take the diagonals 4 times negative 1, negative 4 minus 18, or negative 4 minus 18 is negative 22. Now to form the determinant for AX, we put 8, 1, the answers in for the X column, and we take the determinant of that, so that's negative 8 minus 3 is negative 11. To take the determinant for AY, we put the 8, 1 in the Y column, and so we take the determinant for that, 4 minus 48 is negative 44. And then to get our answers, we take X is equal to the determinant of AX over the determinant of A, which is negative 11 over negative 22, which is 1/2. And Y is equal to the determinant of A sub Y over the determinant of A, which is negative 42 over negative 22, which is 2. So our answer is 1/2 comma 2 for our XY answer. And our last problem is for a triangle with vertices at negative 3, 1, 1, 3, and 2, 1, find the area of the rectangle using a 3 by 3 determinant. So the formula for that is 1/2 times the determinant of this 3 by 3. And as we did in class, remember, we take the first diagonal, negative 3 times 1 is negative 9, plus 1 times 1 times 1 is 1, plus 2 times 1 times 1 is 2, minus, then we go back up. 1 times 3 times 2 is 6, and then 1 times negative 3 is negative 3, and 1 times 1 is 1. So we have negative 9 plus 3 is negative 6, and 6 minus 3 minus 1 is 4. So we have 1/2 of the quantity negative 6 times negative 4, and we're really taking 1/2 times the absolute value of negative 10, so it comes out positive, and so the answer is 5 square units. So again, this is your quiz, and I'm sending the review along with the quiz. So scan those back to me and scan your homework 4.1 through 4.4, when you're done with the quiz, and you'll be caught up for this section.